Okay, so thank you very much, AED Group. I mean, that's for me as well the best setup ever, in my whole life. This is Laurent. So I'm the Director of Product Line Management, Netgear, for the managed switches. I want to thank Jay and the IDK team as well for this invitation. I mean, Charles told you that he was going to feel like Madonna, and well, I mean, it's going to be different for me. I'm going to feel like James Hetfield, from Metallica. Yeah. Welcome to this session. We are obviously going to, have a stop for the lunch, well deserved, and we will start after that. Today, what I want to tell you is actually um, we want to give you the best overview and what it takes, to transport AV over IP. And this is a slide deck that you can put your hands on. It's a 3 hour, in theory, networking crash course. So for this occasion, I have extracted a few slides just for today, but feel free to ask any other possible questions. I'm going to do that in 3 sections, okay? I'm going to explain very basic definitions so that we can speak the same language together, so that we can agree on, what on the AV and the networking side, how we should understand each other. Then after that, I will, directly go to the point and focus on the solution and the AV over IP implementation and how we do it with the SDVE group. And last but not least, I will tell you how to do it. Okay, so I really want to explain step by step how you should configure a network. And I promise, because I'm obviously a marketing person, I won't do much marketing today. Okay, so I have one slide, the next one as well, actually, the only one, which will tell you a little bit about Netgear. But after that, everything you will get from me today will be relevant for any type of Ethernet switch manufacturer. And if I get some questions on Cisco, I would be very happy to answer those questions. So, um, what I mean, I guess you know Netgear, right? I mean, Netgear does a lot for 25 years for home and consumer grade products, Wi-Fi and all that. We have service provider activities. It's another business unit, and I represent the SMB group, the commercial business unit. So Netgear is a networking vendor, obviously, and we're not Cisco. We'll never be Cisco. We focus on the small and medium business side installations, 500 seats, as a size of an organization is what we do. And we do that for a living for years. But something has changed at Netgear. And we literally transformed our organization to actually really become a vendor of choice for AV. And I want to thank IDK and Semtech Aptovision and the entire ecosystem we've been working with for many, many years. We understood that that was a big challenge. And for us, it's clearly a new market, So initially, it was about products. And of course, you need products to make that happen. But sequentially and lately, we realized that it was not the most important thing. The most important thing is, one, we want to make it easier because, if not, you can go to Cisco and spend hours configuring those things. And second, it's support. The organization must support each single installations, especially when it's a live event, because if it's on the Sunday night, it got to work. We must do what it takes to accompany and support when issues, might arise. So the Netgear organization was transformed from a PLM, but also from a expert sales, engineering, QA, and tech support in order to have a much better adequation with this new market for us. So today, I want to just introduce Eric Lindemann. He's our system engineer for Benelux. If you want to get in touch with Netgear, if I do a good job today, you may want to take his business card, not his credit card, it's business card. Okay. So let's start with this short introduction. And before AV, Netgear didn't have a clue. I'm frank with you. I'm doing this job for 15 years now, and I never knew about HD-based T. It was totally out of our scope. And this solution was used, and it's still used. And we can actually estimate that more than half still of the AV installations rely and leverage this matrix switch circuit-based point-to-point solution. So today, well, we think there is a shift, and probably this year is already an inflection point because many new installations go IP. And SDVoE is probably the best of these AV over IP technologies. This time, no more complexity. In the middle of the installation, you have a standard off-the-shelf Ethernet switch that is ready to go. This is your back end. This is the equivalent of the switcher before. And everywhere around this solution, you have a very streamlined topology with IDK transmitters that will encode the video and IDK decoders that will take this Ethernet message and put back the video on the displays. So, as I said, for the first half, and that's what we're going to do before the lunch, let's agree together on definitions so that we can speak the same language. I'm French, by the way. So the codec, what is a codec? Okay, so it's really important for the AV over IP understanding. So the codec sits way above the layer 1, 2, and 3, and 4. We're going to review that. So it's way above the Ethernet basic layers that switches handle, right? So it's totally above that. It's at the layer 5 and even 6, usually. A codec is an algorithm, okay? So that's a system, an algorithm that will take the video, transform the video into something called IP packets, and take those IP packets and decode them to reconstitute the video. Okay? So the codec is usually this step or algorithm when some transformations happen, like compression. You have some other codecs in the market that will heavily compress the video to squeeze the bit rate. HDVoE is much different, but I hope we agree the codec is actually outside of the network transport itself. Bandwidth. So in the Ethernet world, in my world, we measure bandwidth in bits per second. Okay, so megabits per second, gigabits per second, 10 gig per second, 40, 50, 100 gig per second. So that's the measurement of that quantity of bits. So a bit is a data. Don't be confused with bytes, okay, for storage and hard drives. A bit is only 1 bit, and 1 byte is 8 of them. And the bits is the measurement of that speed for the transfer. And you'll see it matters a lot because you need to know that when you calculate your bandwidth relative to video. Latency. So here, that's a good one. I think we agree already, right? The latency is the measurement of time for the delay between a source and a destination. But in your world, well, you measure latency maybe in video frames, but at the very least in milliseconds. In my IT world, we do measure latency the same between what? Well, between one switch and the other, or maybe between one port on the switch to the other port, each hop. We measure that latency in microseconds. Okay, so a microsecond is actually irrelevant for you because a microsecond is a thousandth of a millisecond. And in the Ethernet technology, 1 gig usually brings 3, 4, 5 of these microseconds. 10 gigabit is much more efficient, and fiber ports will bring 1 of these microseconds of each port. Copper will bring 2.5, 3 microseconds max for each port. So in order to understand each other, you'll see, well, we need to know, because when you will talk to an IT guy, latency is not the same measurement. Microseconds matter, you know, for high-speed data, you know, at the stock exchange for the high-speed trade operations, but not really for video. Quality. So this one is for you because I'm not an artist at all. And I was said one day, well, quality, at least you can see it. And that's probably true. But I know you have some very sophisticated processes, to measure quality. Well, the thing is that quality matters, and it might be important from the network stand, because how can you make sure that the quality is maximum? So what some things I've learned is that when you have some artifacts, because you are degrading the video, because you are compressing it so much that you're removing too much information, it creates some quality issues called artifacts. And these will be actually magnified when you will have large displays in venues. So this is probably the reason why, as Charles explained, that, for instance, Sony and Christie, those big display manufacturers, very fast, quick, in the early days, came to this technology, SDVE, because this technology doesn't compress much. In fact, there is no compression at all in many instances, and I will tell you what it takes when it goes 4K HDR. So that brings me to this very important topic, and that will probably be the end of the first half introduction. This is called the codec triangle, and that should be very useful for you because you can't have it all. Okay? It's an utopia, right? So from the beginning, from day one, when brilliant engineers got to think how to transport AV, video especially, they got to make trade-offs and choices, because if your objective is really to lower the bit rate so that you have less bandwidth, then you got to reduce the bits, and you need to compress. So when you do compress, well, you go far away from the high quality other possible objective. Okay, because compression removes information. So there's a lot of marketing funky names here and there, like lossless and all that. But at the end of the day, you do the math, it's not possible. So latency also is sometimes a concern. If, I don't know, you have Anderlecht or another big stadium over there, you have a press room with journalists, and you have all your displays. If there is 3-second delay between the whoo on the stadium and the actual goal on the screens, that's a problem. You look very bad. So latency sometimes is a strong requirement, and well, even further for endoscopy. Anyway, but as soon as you're going to compress, you will have latency going up to the roof, because compression takes a lot of power to actually make that happen. So this is a very well-known codec for a triangle of dilemma. And the SDVE Alliance made, a trade-off. We said we don't care about bandwidth, because bandwidth is out there for years. I mean, 10 gigabit Ethernet is pretty much everywhere already, and 10 gigabit Ethernet gets cheap and cheaper and cheaper and cheaper. But for me, well, it's actually not a problem. So if you remove that condition for low bandwidth, then all of a sudden you don't compress anymore. So there's no more latency, and the quality remains. I mean, it's meant to remain intact. Okay? So this is, the basic definition of what SDVE technology and IDK IP-NINJAR does. SDVE technology, of course, can transport 720p and 1080p. I will tell you that real soon. But 4K 60 HDR with 444, it's actually, our value proposition. We do transport 4K HDR without any degradation of the signal quality and without any latency. So I need to be frank with you. I mean, three years ago, I had no clue whatsoever what 444 was about, and somebody actually much more intelligent than me told me this. It's actually chroma subsampling, and all of a sudden I said, okay, color photographies. But in fact, it's not that. HDR is the only way to display my stuff, a Microsoft Excel big spreadsheet on a large display. Because, Excel spreadsheets, you have so many small lines and small contrast and small fonts, fine prints, that without HDR, you have a very bad Microsoft Excel experience. And I'm an ex-Microsoft guy, so I know what it takes. So 444 is actually very necessary because it is a guarantee for all the difficult patterns that many of your applications will have. And this is one of these typical patterns. 422, you are losing information and you cannot read anymore. So this chart, if there is one slide that you should keep out of that deck, is probably this one. This is the actual transcription between the native video on the left-hand side and the quantity of bits. Okay, so the actual native bits rate for those videos. And well, as soon as you leave 720p territory, your native bit rate is already beyond 1 gig per second. And 4K 60 444 is 12 gig per second. Okay, so that's huge. I mean, that's when you can realize that when you transform the 12 into 1, that's a huge, massive compression. So that's why latency is many video frames. So some of you might tell me, yeah, but 4K HDR, it's actually more than 12. It is. It's 18, I believe. But in fact, what is removed here is the HDMI itself, the HDMI overhead, that is not meant to be transported. It would be dumb because you can actually calculate it and recalculate it on the other hand. So you don't need to transport the HDMI overhead itself. So that's the actual native video, okay? Remember that. 4K 60 444, 12 gig. 1080p, I don't have my glasses for that little one, but that should be 3 already. So 12 gig in the SDVoE language turns out to go down at 10 gig per second. So this is the actual solution, okay? And now it's time for the second part of this demonstration. I want to explain in great details what happens on the network, the middle of that section, when you plug IP-NINJAR's encoders on the left and decoders on the right. Okay? And after that, again, we will actually set it up ourselves together. So, a few words about this solution. That's a very simple representation because here you have only one big switch in the middle, right? So that's your metric switcher. But see, it's not about only video, right? Because this technology is so great that in addition to your main video feed coming from the left sources, you can transport a whole lot more of IOs. Because in every job, you need additional audio inputs, or because you are decoupling audio, or infrared RS-232 for control, even Ethernet. There is an Ethernet port on many of the IP-NINJARs, if not all. And you can actually transport from left to the right a standard 1 gig Ethernet connection, so that you have your, for instance, Dante audio, whatever else, transported. And I really wanted to make a point with the USB capability because Charles actually spoke about KVM, which is actually a good one. But I discovered myself, real world, one day, something incredible. So I want to share it with you. If you have a PC on the left over there, and you are connecting the USB port over there, if you have a thumb drive, a USB flash key, you can actually get your PC on the other side and connect the USB port on it on the IP-NINJAR decoder, and you will see your actual storage, your flash drive, as if that flash drive was actually there. So that's way more than the dumb keyboard video monitor thing, right? It's a real USB 2 implementation, which is awesome. And I mean, as far as I know, to do that with an HD-based installation, you need a hell of additional processors or whatever it takes to make that happen. So let me back to my point. How does it work? Well, we said 10 gig. Okay. In reality, there is something to know here. The video coming from the left can be first something else, right? So if that's a 1080p native video, well, there is no compression at all. So the IP-NINJAR encoder will take it and turn it natively at 3 gigabit per second. So knowing about the resolution and the chroma subsampling information from your sources is really important, because that helps you calibrate the overall bandwidth requirement for your installation. But now let's say this is actual 4K 60 Hertz 444. The SDVOE mechanism, this great technology, will take that signal and make a 1.4 to 1 compression. So this is a very light algorithm, real fast, because it's actually a very small compression that doesn't bring any latency from a video frame standpoint. And you get 9 gigabit per second for the video, the main video stream. Okay? So this is how this technology can reserve 1 gig, a real 1 gig Ethernet bandwidth for everything else on that chart. Okay? So your Ethernet port, if you want to transport some control protocol or some management for the lights or whatever, or if you have some actual 1 gig Ethernet transport to make for audio, all the IOs, RS-232, infrared, and all that, audio, and USB. Okay? So that's very important, because, well, other technologies at 1 gig, well, we know now that taking 4K HDR and compressing it so much, that it's squeezed into 1 gig, you don't have much left to do everything else. It's even if you have USB ports or whatever, I/O ports on the boxes, it's quite utopia, right? Because the remaining bandwidth out of a NVX box is going to be maybe 10 meg per second of actual bandwidth available for it. So that's how SDVOE works, right? Maximum 9 gig per second, 9 gigabits per second of bandwidth in, and in the 1 gig additional bandwidth that is there, you can squeeze all the IOs, you can squeeze USB and Ethernet, and also, to be technically correct, you have the second stream of that video that is low scale, low scale, so that this second stream can be used by the other IP-NINJARs to do multi-view simultaneously, multi-view applications. Am I right? I guess so, yeah. Cool. So I want to explain now what is the theory. And let me introduce that this way. I believe that you, in the short-term future, could be in either of these two groups. The first group will be technicians, installers, contractors, customers, trying to do AV IP installations by following the book, following the book, commands by command and line by line, and you will get it done. And but should something bad happen, in your language, very often for live events, you say something like, when the shit hit the fan, you're in trouble, because it's not in the book, And the second group are probably technicians or installers that know better why, the reason why we do all these things, so that you understand it. And if you know about it, then you do the job, and if the shit hit the fan, you know where to look, you know? And bear with me, but I want to put you all in the second group right now, okay? So I really want to spend time, half the time until the coffee break, to let you really understand what it takes. So for sure, we need to go through these notions together. And multicast right now, I'm telling you, multicast must become your best friend. Okay? So let's go through it. Well, let's go to this OSI layer model. And it's very simple because the networking things are all at the bottom of it. And that's really simple. Layer one, it's the cabling, okay? The material physical layer. HDBaseT use the same, actually. This is the only common small thing between Ethernet and HDBaseT. So fiber, copper, you know. The second layer, very interesting. The second layer is the physical MAC address layer. So this is how a switch, the switch that you have at home in your internet box, you have a small switch, you know, RG45. All this switching is made based on the MAC address, source and destination. So this is how switches can move those packets. The layer 3 is a little bit more challenging. It's the IP layer. So on top of the source and destination physical MAC addresses, you have a logical address called the IP address, and you may recognize what you have at home, right? Class C, 192.168.0 or 1.0. So switches can actually do also IP-based switching, and this is called routing most of the time. And the layer 4, it stands for the port. So after the physical MAC address, the IP address, you have the port information. And I'm pretty sure you know what it is. If you use a browser like Chrome or Microsoft Internet Explorer, if you go to, I don't know, www.google.com, which port is getting used for these networking messages? It's the port 80. Okay, so the TCP port 80. And this port is by definition always open because it is the internet HTTP communication port. After that, you have more secured ports, of course, for HTTPS. If you go to your bank account, for instance, that's better to use security. So the port, you have two kinds of ports. You have the TCP ports for point-to-point, and you have UDP. And UDP is another low-level categories of ports, and multicast is that, UDP traffic. Okay? So now, in order to understand multicast, you need to know what's not multicast. So what's not multicast is, first of all, unicast and broadcast types of communication on the network. So in order to illustrate that, I would like to play a game with you. Okay, so let's say we have a small switch. Actually, it's a Netgear, but it doesn't matter. And you have this brand new switch out of the box. You put it on the table, and you have 3 of your PCs: PC A, PC B, PC D. C, sorry. And you see that you can statically assign an IP address to it, right? So even if you don't have a router, DHCP server, you can statically say, you, PCA, are 192.168.1.1 and 1.2 and 1.3. MAC addresses, you cannot fix that, right? Because you just look under the label on the PC. Any network device, there is a printed physical MAC address. You know, it's fixed. And when I was a kid, I thought that there was a big worldwide organization distributing MAC addresses to everybody. That's a fake. It's all random. But you have a very minimum chance to see 2 devices with the same, okay? And if that happens, well, the shit hits the fan because the switches can't handle that. You know, they are not meant to survive. So you have, for the sake of this exercise, very fake MAC addresses, but A, B, and C. Okay? So the game is you want to use the PC A and you want to ping the PC C. Do you know what's a ping? It's a query, so you want to know if that IP address from the PCC is reachable, and you want to know how much time it's going to come back, and if it comes back. Okay? So in that case, guess what happened? It's a beauty. You are actually asking to the PC with the ping 192.168.1.3, you are asking the PC to do a whole bunch of operations. First, the PC is going to send a query because he has no clue who is 192.168.1.3. And this query is, technically speaking, a broadcast message. It means that this query is going to be broadcasted to every single node on the network. Who is that? Okay? And that's heavy communications, because you'll see it's a whole bunch of network traffic. So the PCC, as any other device, will get that query, and the PCC, first of all, will make something magic. It will, on its own, build its own table, because now it got a packet originating from the 1.1 IP address, and in this packet, there's always a MAC address, a physical address as well, so it knows the correspondence, the table, ARP table between the two. Now, this PC is going to obviously react, because that's how Ethernet works, no matter what the PC is, Linux, Windows, and he's going to answer, hey, it's me. You know, so that's a typical hello message. Hello 1.1, I'm 1.3. And this message, this time, is getting only to a destination, which is A. It's unicast. Okay? So broadcast, that's something that's going everywhere. Unicast is a point-to-point TCP session, because the PCC knows exactly where to send it, you know, because it got the source MAC address and it got the origin IP address. So broadcast versus unicast. Now the switch got a whole lot of information. He knows at the layer 2, at the very least, which MAC address is on which port, you know? So now you understand that if you want that information, this information can be found in pretty much any switch. You are going to query this table to see where, or you know, which port got such a MAC address. Now the ARP table, now that the TCP unicast message back to PCA, the ARP table can be built on the PCA. You still don't know. I mean, you had no clue so far, right? But this is what's happening real fast. And PCA got a table now. He knows the correspondence between a physical MAC address C and an IP address. And the ping can happen. So now think about a network like this AED building network. You probably have big switchers, and you probably have plenty of Ethernet devices. If one of these devices was sleeping for the last couple days and just wakes up, guess what? He's going to have to, I don't know, print something, you know, or send a message to somebody else. This is broadcast, right? Because any single activity from that PC searching for an IP information, this query is broadcasted to everybody. That's a real shame. In the IT world, broadcast is the enemy, you know, because it can saturate bandwidth in between switches. You need to know about it. Especially because if another PC was sleeping so far and this PC wants also to do something, badaboom, again. You know? So bear in mind that broadcast is an enemy, and we must have some strategies in order to fight broadcast. So what is the best strategy to fight broadcast? The answer is just restrict the domain. So instead of having a big network, just put together smaller networks, because the less devices, the less ARP queries and messages. But, well, that's not a network anymore, right? You have two standalone different networks, so that doesn't work. So this Ethernet technology was great from day one, because from day one, we knew how to restrict the broadcast domains by segregating the networks into different separate VLANs, virtual networks, a red one and a blue one, which then can, restrict the broadcast. For instance, a PC originating from the VLAN red, the broadcast will stay local to the VLAN red. So in local area networks, usually you don't have only one switch, you have some switches, always in a star topology. Don't do rings, right? Like token ring in the old days, it's over. So Ethernet doesn't like loops. So you have a star network and you have maybe 3 switches and there's always a center. And in this example, the center is actually the router, the internet firewall gateway. And you can actually ask your switches to do VLANs for green VLANs, the accountants, the blue VLANs, the video, and the red VLANs, the bad sales guys. So if you do that this way, you can actually virtualize the whole thing because a switch is capable of, separating that individually in switches. So that's what we call doing VLANing. And in that a typical example, you still can provide internet to every of these VLANs by having a router at the top that is aware. So the router will be doing internet for the blues, the greens, and the reds. But my point now is that you can actually do that, stay layer 2 on the switches so that you have the layer 3 routing VLAN things up there. But you can also move that function into the switches, and that's what we call a layer 3 switch. So a layer 3 switch, usually a managed switch, is capable of doing that for you. You don't have any more requirements for routing outside. The switch is capable of doing layer 2 MAC address-based traffic and layer 3 routing at the IP level, even, for instance, sharing internet across greens, blues, and reds. Yep?
Very stupid question.
Oh, there's no stupid question.
The answer to this. Oh, wait. Sorry.
Stupidity is the guy who doesn't know the answer.
So, well, that's me. I'll claim that. No,
joking.
You've got MAC addresses
Yes.
on all those computers. In theory, they're all different. Why bother with IP addresses? Why not just go straight to the MAC address?
Oh, absolutely right.
How does it help?
It doesn't help. Most of video installations you will see with me will stay at layer 2. Okay? Most, if not all. But, in the IT world, you had to go VLANs because I just told you that if you have a large network, not home, right? But here at AED, if you don't have VLANs, the network is bombarded all day long by broadcast. So by restricting that, you do VLANs. As soon as you do VLANs, you got to go layer 3. Okay? So if you don't have that problem, if you do not have any VLANs, you absolutely do not need layer 3 IP address communications or strategies. Does it answer your question? Cool. So now, you know broadcast, sending to a message to everybody. You know unicast, a communication between 2 devices. Multicast is the next most brilliant invention that probably allowed for internet 25 years ago. Because multicast is the 3rd type of communication in Ethernet world. Unicast, you know the MAC address, which is printed, the label, the IP address, which looks like 192.168 for class C. You have class B, you have class A, 10.0.0.0. It's a very classical scheme. Broadcast, the MAC addresses that are getting used are logical this time, and they have specific MAC address for it. And the IP address also at the layer 3 got a specific reserved range. Multicast is another animal, right? So this time, the multicast MAC physical layer 2 layer address is different from the others, you will get used to it. 01005E, that's what the IP IDK NINJAR controller will tell you, to identify a multicast source. IP addresses are different, and MAC addresses, MAC addresses are different, and the IP multicast addresses also are different. One well-known is 239 something. So multicast is a beauty because without it, no internet, right? Because how can you imagine having any internet if all communications are one-to-one? It's physically not possible. And the same if you bombard the entire internet with broadcast, there's no point. So multicast is a beauty because we were yesterday at a dinner with AED folks, and that was really funny because we said, remember Jesus with the table and the bread? Jesus took one piece of bread, and it got multiplicated. Multicast, that's about it. So you have a sender, like in your world, a transmitter that is encoding video. This message is sent only once to the network, and the network is duplicating this, but only to the interested receivers. That is multicast, okay? So, well, I must apologize. We should not quote Jesus in a public session like this. So take it away from the cut it off. But that's exactly what it is, okay? Multicast. So now let me explain to you in great details. So my goal, before I go with IP-NINJARs, to make it very simple, I took, and I'm not an artist, okay? So I'm sorry, this is very low-grade drawings, but you have a Mickey Mouse kind of a IP camera, okay, that you have set up to do multicasting, not TCP, but multicast. And you want to have that camera hooked to a main switch at the top, but you want that video only on 2 pieces down there, okay? In order to make that happen, unfortunately, that's not natural. You must have a few protocols on switches that you must configure to allow for it. And these protocols are called IGMP, all the IGMP protocols. So let me explain the first component of it. The first component is called the IGMP querier. So, well, the name is the name. In the old days, when I was at school, we used to call that a multicast router, okay? But it's gone now. The standard, the RFC, talks about querier. So the querier used to be a dedicated device at the top of the network, usually a Cisco router that was missioned with that querier mission. And the source, Mickey Mouse, is delivered, and this querier is detecting it, so that is acting a little bit like a detection mechanism. And you can understand it like a database somehow. So this source of multicast is going to be registered, and the querier is responsible for one thing, asking the question to everybody on the network, do you want to get it? So do you want to get Mickey Mouse? And guess what? This form of communication, this IGMP query, is broadcast. Because that's what it is. It's broadcast messaging. And if you only have that, well, still you're not there. Because without something else called IGMP snooping, despite you have a querier, your Mickey Mouse video will end up flooding the entire network. So this multicast source will be transformed into broadcast as well, okay? And this you don't want, right? Because it's criminal. You don't want to bombard networks with videos that are getting delivered to every device. So the second component is called IGMP snooping. So this one is a tricky animal. So let me explain. IGMP snooping this time always resides on switches. So the switch down there must have this function enabled and properly configured. So what it happens is that when the querier is sending the question to everybody, do you want that video? Only one in this example, A, is going to say, yes, I want it. Technically, it means he's willing to subscribe to that video. And the result is that A is going to send an IGMP join message down to the querier. I want to be part of it. In fact, I want to receive that stream. So this IGMP join message is sent back to the querier, and the querier can actually organize the table between sources and destinations and put together the groups, the bindings. But the switch is going to snoop on that IGMP response. It means that the switch on its own is going to listen and understand the IGMP join message, and the switch will actually say, okay, there is something going on, there is some due multicasting. I am going to block that multicast stream first, not flood it everywhere because it's registered now, and I'm going to replicate that stream only on the port number 1 for the PCA. So IGMP querier plus IGMP snooping make the whole thing work. Okay? So I used Mickey Mouse dumb IP camera. It was just for you to better understand it. If you don't, please tell me that's the right moment before we go further. But if I go back to this installation with IP-NINJARs, there's the encoders and decoders, so the source and the destination are pretty passive elements, actually. So all that subscription, how you instruct the system to subscribe to something A or something B, is done via the controller. Okay? So when you will physically see this afternoon how to move or slide a video source to a destination, by doing that, the controller is actually instructing those devices to do this IGMP join, IGMP leave things, So this is totally transparent, and this is how this system works, and this is how switches understand that. Yes?
Who wanted it?
So there is IGMP version 1, 2, and 3.
Yes, this is correct. So you'll see that later. From a requirement standpoint, the SDVOE ecosystem is leveraging IGMP v2 and IGMP querier v2. The reason is that it's the most widely adopted IGMP across all switches, pretty much, and this is a further guarantee for interoperability. Okay, so IGMP v3 has some advantages that we might discuss offline, but this is not used. This is not a requirement for IP-NINJAR, for instance, v2. So the good news is that these old days are gone. The IGMP querier is no longer an independent device. Well, if you still want to give some money to Cisco for routers to do that, you can. But most switches embed IGMP querier and IGMP snooping in the switch, so that you just check those boxes when you spec a network. I want to have IGMP querier. I want to have IGMP snooping on my switch so that my multicast video over IP can work. And this is not exclusive to SDVOE. In theory, we hope any other video over IP technology will do the same, because this is the only way to make switching work. You must be compliant with querier and IGMP snooping. So yes. Maybe I should keep it myself. I'm sorry.
Yes, Jay.
12 kilometers later.
Coming back to your previous slide, so I'm not an expert at all,
Oh,
but I know that when you have an IP encoder, for example, you need to specify the source IP address and a destination IP address.
With NVX, yeah, without the NVX director. Not with SDVOE. There is no such fastidious and so dumb point-to-point programmation. So the SDVOE
But
philosophy...
for example, in
Yes.
SMT 2110, you
Oh.
need to do it.
Yeah, okay, yeah.
So
Sorry.
for example, but
so
there
sorry, I
are
was wrong. I was shooting for Crestron NVX, so you shoot for 2110. That's
no,
right.
But for example, but how would you translate that source and destination IP address into something like that?
You don't have to. You don't have to. So if you do it manually, so if you don't have a beautiful, fully functional controller that allows you for, doing, I want this source on that TV, I want this on this video wall, if you do program, on the TX, and if you get that stream multicast information from the TX, and if you go program the RX, then by doing that, you provoke IGMP join message out of the TX. There's no magic. You're always down to IGMP compliant mechanism so that the switch can snoop on it. Even if you are under the impression that you are programming the switch, you're not. You are programming AV, TX, and RX that will then, because they must interoperate, behave in such a way that they comply with the RFC, somebody help me, 21 whatever, and consorts, to comply with the IGMP requirements. Yeah, and no, the querier is still in the switch, in theory. So the question was, is the querier inside the device? It's never the case. It's not meant this way. Again, it's at the end of the day, it's not super important if you make a difference. IGMP querier is a database, ultimately putting together the IGMP groups. But the snooping is essential because with snooping, the switch can actually make it happen. Yes?
So when you talk about the controller for kind of routing which source should go to which endpoint, the controller, could we view this as controlling the IGMP querier?
No. So I'm happy to get those questions now because I want you to be in the second group, okay? So when you are manipulating the controller is going to send orders to especially to the receivers on the right. So the receivers get that information in such a way that they will send an IGMP query to the switch and the querier. So you just, if you wish, facilitate this. I know what's wrong. Okay, so let me take another example, and I promise you will be up at 2:30. Everybody knows VLC player. Okay, so on the PCA, you have VLC player, you play a movie, this one, and you use the file menu on the top left, and you will find an option to actually trigger the server function of VLC player. And this way, you are transforming that VLC player into a multicast source, right? And instantly, this source is getting to the switch as a multicast stream. So first thing, if you do not have IGMP querier somewhere on the network and IGMP snooping, the whole network is going to be bombarded with that stream, so don't do it, it's criminal. Or if you have an organization you really want to annoy, just come and put this. I can tell you the whole network is down, right? Because you will saturate all the uplinks, all the ports. So if you do that, if the switch has the querier and the snooping, the querier will detect that source. The querier is going to send the query to everybody. Who is that? Who wants to subscribe? The switch will snoop on that, so the switch will immediately block that video so that you don't flood. And you take another PC, you open VLC. This time you select the other thing, file, open. And instead of opening a file locally, you will actually copy and paste the multicast information from the source in there, And by doing that, opening a multicast source in the VLC player means that in the background, your PC is going to send an IGMP join message to the carrier, that the switch will snoop, and that's how the communication will be made on the network. So the controller at SDVOE is meant to prevent that fastidious thing, so that instead of forcing the TX and the RX, you actually administer from a central point your communications, but it's down back to the IGMP rules.
So the communication between the controller and the devices will be unicast to instruct them to send subscribe messages to the IGMP carrier.
This is half correct. In fact, the management protocol that is used between the controller and the TX and RX, it's kind of a multicast protocol as well. So, because initially there is a discovery protocol, and then you're right, when there is a communication, this is a one-to-one multicast. So that's a very specific and very efficient multicast scheme that is used. No interference whatsoever with switches.
Thank you.
We have a question on the right side.
Okay. It's my turn now. I'm running.
So if you have a source hitting all 4 of your PCs, A through D, in multicast, is there any difference now between multicast and broadcast?
Well, it's still multicast type of traffic, but it is actually badly imitating the broadcast traffic.
So is it then more efficient to be broadcast traffic if you needed to hit one thing to many? Or is it better to stay
No,
multicast
because
then?
even if you would like to do it, most AV encoders and decoders, they don't talk the broadcast language, so they don't use those broadcast MAC addresses or IP addresses. But did you know, who knows about IPv6? Everything we've said right now applies to IPv4, right? So, but service providers, public IP addresses, so not the 192.168 that are residential or the 10.00s, but the public IP addresses, they got rid. I mean, they don't have any more available IPv4 public addresses because it's only a combination of numbers. So IEEE came with the IPv6 new scheme, so it's a very big IP address with characters and letters and numbers, so potentially millions that are available. And one day we were said, oh, IPv6 is going to be the new thing, so we networking vendors spent a lot of time to put IPv6 everywhere, and guess what? It never happened, right? So IPv4 still is used for local area networks, IPv6 for WANs. In IPv6, there's no more broadcast. So IPv6 said there's only two forms of communications now, unicast and multicast, because multicast can achieve broadcast, right? Okay? So I need to wrap up now for this second section because I really want to set up things with you. So multicast. Let's say we have 4 PC. There is a multicast stream. The switch is blocking everything, essential, right? You want that the switch blocks every new video source because you don't want to flood the network. The switch at the carrier level in the switch is sending a request to everyone. Do you want to subscribe? So the PCs are going to build this report subscribing to either a multicast physical address or a multicast IP address. So you can see that the PCA in that case is willing to subscribe to 2 different multicast IP addresses. The PCB only one, the PCC the other one, PCD nothing. And this is happening in case of IP-NINJARs when you actually at the controller level move your videos, you make that happen. The decoders on the right-hand side will put those reports together. So they are going to respond. The snooping table will associate port 1 to 2 different multicast sources. The snooping table in the switch will associate the port 2 to only one of them, the port 3 to the other one. And this is how the query works, the answer, and I'm done. Okay, so I want it to be very clear with you because, as I said, if you want to be in the second group, you need to know, because when there is a problem, Now I hope that you will be able to instinctively try to find if is there a querier, you know, is there snooping, you know, that are the very important questions for you. So everything I said, I believe, were technically correct, more or less, and apply to every networking vendors. If someday you are asked to deal with distinct VLANs, you should step off, you know, and say, oof, 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 oof. Multicast is not meant to travel from one VLAN to the other very well. Because like broadcast, multicast is IGMP. IGMP is meant to stay within a VLAN. So on a typical job, that would be better for you to assign a VLAN for video. For instance, I don't know, the VLAN 200 for IP-NINJAR and equipments and controllers, all that. And maybe if you have some Dante audio coming in the same network, then you will assign another VLAN for Dante primary, VLAN 300. And maybe if you have a secondary Dante, then VLAN 300. Keep it separate, but keep the video IGMP into the same VLAN. Why? Because as soon as it's not in the same VLAN anymore, layer 2 doesn't work anymore. We got this question on this side. So you're screwed, because it's not gonna route, it's not gonna traverse VLANs 200, 300 this way. You need to provoke it. That's very fastidious. IGMP is layer 2 kind of operation, when multicast routing is a totally different animal. And multicast routing is complex because it requires unicast routing plus multicast PIM routing. PIM SM, PIM SSM, all that. We cannot talk about that today because, well, I mean, it's the other level. That's how Belgacom maybe handles IPTV globally, you know, in the country here. But frankly, in 15 years, I don't do AV for all that long, but for the last 3-4 years, I've never seen a video over IP installation with IP routing, okay? Because it's too complex, too fastidious. You should stay at layer 2, meaning you should stay within your VLAN, okay? One VLAN for all. So if ever you have this question, you can default back on something great called multicast VLAN registration, MVR. So it was invented by Cisco maybe 10, 15 years ago, and since then all of us, we do it because we reversed engineering it. And it's great because you can actually assign a video VLAN, like the video VLAN, the VLAN number 10, and put all your IP-NINJAR sources in that VLAN, all the transmitters, okay? And with that function, which doesn't require more than 3 clicks in a GUI, you can actually then tell the switch, okay, my video VLAN is the 10, but I may have clients, receivers in the VLAN 1, 2, 3, 4, and so on, and so on, and so on. And you can actually have this IGMP working from the video VLAN to the clients in other VLANs. Like, you know, just telling the switch which VLAN he should look at and which port, okay? So it's a great function because it works great, it's very simple, doesn't take much in terms of configuration, and it's gonna save your life, okay? Yeah, this is the switch. It's a switch layer 2 feature, multicast VLAN registration. But let's ignore that for now. Let's say we all agree, okay, the IP-NINJAR VLAN is gonna be the VLAN number 1 or 2 or 200, doesn't matter, but just 1 for every AV device for video, okay? So before we configure the switches, I was willing to say a few words about QoS, because after all, you came over here to get some basic, I hope, good quality notions for Ethernet, so we need to talk about QoS. But let me tell you this way, it doesn't really apply to video, because it can't. But what is QoS? Well, quality of service was developed initially for the little tiny types of traffic, like voice over IP, that could be attacked or maybe delayed because of those bottlenecks in between switches. So you can, with QoS, differentiate types of communication services and put voice over IP into the fastest queue. In fact, there is only one way, right? So you just tell the switch if you have a bottleneck, the absolute priority is voice over IP packets, because emails and everything else can wait, because you know that in voice over IP installations, if you have those delays and latency and jitter, the voice is bad and the quality, the user experience is bad. So it is possible because the switch has some buffers, memories on each port, so you can actually store a little bit of data and delay some classes of service. Video, forget it. Okay? Because video with IP-NINJAR 10 gig equipment, it's 10 gig big flows, right? You would need a terabit storage SSD drive on every port to do some delay or manipulations for QoS. So it's not meant to be used, okay? But in your VLAN for Dante, maybe, because Dante requires some tiny MDNS bonjour packets with some TCP, some PTP. So you have all types of small pieces of traffic that you will really need to prioritize. So Dante configuration requires QoS, okay? Not video over IP per se, because it's impossible. So what is the learning? Any guess? The learning is that you can't stand bottlenecks with video. It got to go through. Because if it doesn't go through, you will have, very bad experience, okay? There is no way to apply those DSCP strategies for multicast. So the last thing I got before the hands-on is the switching fabric, because now you know that it's really important. You must have capable switches without bottlenecks. So how do you calculate what is a switch fabric? In the old days, we networking vendors build those horrible big switcher called chassis switches, and now only Catalyst or Nexus 9K, 11K, big data centers, they still continue, but since then it's not really much a thing. We all prefer pizza boxes, because it's more convenient. You can place them where you want. But in the old days with the chassis switches, we were talking about the fabric. So how does it work? Now it's in a single switch, at the switch level. You need to calculate that fabric. So the trick here is that you need to know what is full duplex. So what is that? Simplex. Simplex, it's a one-way communication like radio, okay? Doesn't apply to Ethernet. This other type of communication is called half duplex. Remember the talkie-walkies? So if somebody is pushing the button, speaking, the other guy, even if he pushes the button, doesn't work because it's not bidirectional. So half duplex is pretty much like what AV over IP does, right? Because at some point, a transmitter is transmitting and a receiver is receiving. But it doesn't really apply to Ethernet, because we said earlier that Ethernet was by nature always full duplex. So if you have a computer Macintosh A and B, you can just put a RG45 cable in between, and you can actually send a file, copy a file from A to B at 1 gigabit per second, if your computer is capable of doing that. And you can do the exact same on the computer B, sending the file to another file to computer A. You will really have bidirectional communication, 1 gig in, 1 gig out. Okay? So for the switch fabric, this is the same thing. Between two switches, any link is capable of doing bidirectional traffic. So that kind of limits the bandwidth requirements, because you cut it by half, right? You know that you need to calculate based on full duplex. So 10 gig, same thing. 10 gig on the left and 10 gig on the right at the same time. So the switch fabric should be a good switch, should at least give you what? If you have a 24-port switch like this guy, the Netgear 12X12F, you have 12 copper, 12 fiber, all 10 gig, 24 total. The switch should be capable of doing 10 gig on every port, and you have 24 of them, so the magic formula is 12 plus 12, 24 ports, times 10 gig, 240, times 2. because if you don't have 480 gigabit per second of switching fabric on any switch you want to use, you won't be able to do line rate fully bidirectional types of communications, okay? So remember, that's easy actually. You take the port count, what is the speed, multiply by 10 or 1, and then times 2, okay? So please do not procure any switch that is not like that, okay? Not line rate. We at Netgear never did it. But in the old days, some switches out there were using some kind of weird implementations, and it was not the case. So that's an absolute requirement for you, okay? So bottlenecks now. A switch with a line rate non-blocking switching fabric shouldn't have any, right? So if you have 3 IP-NINJARs transmitters up there, 3 receivers, obviously there's no bottleneck, right? Because the switch is line rate. Of course, we said that doesn't matter for the switch. You can have any kind of asymmetrical installation with 1 source and plenty receivers. Doesn't change a thing from an Ethernet standpoint. Now the problem is, yeah, the animated GIF is working. Well done, guys. 2 weeks on the road with Jay and IDK, that's the first time I got my tube, my pipes. That's nice. So good stuff. So you see, here you have 3 switches. Let's say you have a job, a small opera house maybe, and you have a switch on the main video room or server room up there on the right, and you have a stage, and then you need a switch on the stage, and you need a... Oops. I hope you remember, though. And you have the switch down there with the another building, maybe. So whatever you have in the between, it's going to be, you know, links, fiber, whatever. This yellow thing should be your obsession, okay? Because your obsession should be, how can I be line rate? Because now you know that video cannot be prioritized or diff served of any sort. So the yellow pipes are actually usually the blocking thing. And my illustration used to show that even if you are very proud of your plumbing at home, you know, because you have big pipes at the restrooms and everywhere else, if somewhere under the house you have a small section of pipe, this small section is going to restrict the entire water flow. And that's cruel, right? And that is exactly the same thing here. So bear with me. We need to go faster. Bear with me. Let's calculate it. You have 5, no, sorry, yeah, 5. I don't have my glasses. 1, 2, 3, 5 transmitters up there. So for the sake of today's presentation, because I want you to be in group 2, right? So let's say they are 1 gig. So other type of IDK encoders, like H.264 encoders. How much bandwidth should you have on the yellow link going down if you want to transport 5 H.264, whatever, 1 gig videos? Only 5, right? I have 5 on the right. If you want to transport those 5 streams of 1 gig, you should, I mean, you should say 5. Yeah, it's 5 times 1 gig each. So 5 gig down here. So it's already more than 1 gig link, right? You need a group at least of 5. Okay, you need to link, aggregate, or group together 5 links. Or you can go 10 gig. With 10 gig, you're covered. Now, well, nobody really noticed yet, but what do you have down there? You have only 2 receivers. So in an AV over IP installation like this one, how does it work? Well, those 2 guys, they can only receive 1 stream each. So in fact, you only need 2. Because at any single point of time, they will subscribe to 2 max. So now it's time for me to tell you that your obsession should be this. And what is the typical IT admin guy's obsession? What are they obsessed about? You know? Their obsession, the money, that's a good one. No, if they would like to have a unlimited budget, that's what they would like to. But it's not, hopefully, a democracy. So their obsession is the uptime. They are obsessed by any possible single point of failures. Because very often you have some applications like virtualization, convergence. If the CEO is actually using voice over IP to do an investor day call, if it's going wrong, usually the IT guy is gone. Well, so it's not your case. You don't care much. I mean, you do, of course. It must work. But in AV, in general, you have many points of failure, right? Any device is a potential single point of failure. But instead, your obsession very often, I noticed, is about how this system can scale. Because your clients, they always want more. And that's why HD-based symmetric switches were no good, because if you have an 8x8 or 16x16, 6 months later, you have to redo everything. So in Ethernet, this is gone because we say Ethernet is expandable by nature, but, well, that's true. But still, you have the yellow links to think about, okay? So please calibrate. And because you should be obsessed by the future, you should not hesitate any time to put more capacity right now at the first job so that you're covered. Because if that day the client is going back to IDK and saying, well, I have 10 more sources and 5 more displays, the network should sustain that, okay? So not only go at the exact strict limits, you should plan for more. Ethernet is actually very cost effective by now. So now at 10 gig, let's do that at 10 gig with IP-NINJARs over there. You have 5, it should be 50 gig max. But you have only 2 down there, so you need at least 2 times 10, 20 gigabit per second of traffic. Okay, I did not lose you. And see, my animated GIF works again. That's great. Yes, go ahead.
Okay, you have your system like you just drawn.
Oh, yes.
And imagine you have a colleague that's not aware of the network topology, and he says, oh, I have 10 ports available on my switch, and I want to plug in 10 additional receivers subscribing to these encoders. But he's not aware of the pipe that's only 25 gig, for example, between the 2 switches. How do you avoid oversubscription then?
Oh, that's a brilliant question. How do you avoid oversubscription? You need to do something for it because it's not natural thing for switchers to refuse, right? So first, you should document. Any job should be documented somehow because so far you were probably documenting the sources, the displays. Now you should also document that, what is the capacity. Second, it might work. Because if you add, I really need to speed up, right? So bear with me, I'm going fast now. If you add 12 or 20 decoders up there, doesn't matter to me, right? Because after all, you don't have any video source coming from the left. All the video sources are on the right, and the switch is line rate. So all the ports that are free where on local switches you have TX and RXs, you can add as many as you want in the future, right? Because remember, the bread is getting multiplied. So now, if extreme case, you only have 20 gig of bandwidth right there, because you have only 2. And now if you add 10 more there, potentially they can subscribe to 5. So from 20, you go up to 50. And then you are going to oversubscribe. So what is the symptom when you do oversubscribe? Switchers will do the best they can, but multicast UDP is best effort, kind of a delivery. So you will, the good packets will be bombarded by bad packets, and they will fight, and you won't have nice results. So the only way to prevent that, the simplest, is that when you're done, when you have finished your job, lock the switch. Not physical security, kind of a locking in the cabinet. Just go into the switch and lock it. So you tell the switch any port that is not getting used, I lock it. So any new device, you, me, whatever new device plugged into those ports, there will be no link because you have locked the MAC address table. That's the easiest I would do right now.
So there is no type of SDN layer preventing you for doing
No.
stupid things?
No, no. At this stage, there is no such. SDN, software-defined networking, involves other kind of messaging, like OpenFlow or whatever. We support that, but we did not implement it for this. Second point, you can use a monitoring system, like a network management system, so you will actually get alerts as soon as you go above a threshold in terms of bandwidth utilization. You have many strategies, but the way, tell me if I'm wrong, but if you are responsible for an AV installation, if you are committing for an application, and if you have plenty of free ports on the products, you should lock it down, right? So that at least you are called and you get a ticket, whatever. When time comes, we need to add more. If you don't have control, I think everybody disagrees with that. No.
Just a quick summary could be your bandwidth is dependent on your inputs, your encoders. You can have many
Eric?
encoders on the other end, right?
Yeah.
Oh, sorry.
So the summary,
Just raise your hand, I'll bring you the mic, and then...
the summary is.
Sorry about that. So just let me just say it again for the record here. You're determining your bandwidth on the links based on the encoders. You can put as many decoders at the end. That link is not going to be affected.
Yeah.
It's really how
Yeah.
much you have to send
So
simultaneously.
if we have mathematicians in the assistance, I believe that the correct formula should be minimum of the number of pairs between TX and RX on every switch. That's how, because whatever the number of TX is or the number of RX is, what is important is the number of pairs that can happen. Okay? Number of pairs, minimum number of TX and RX. Okay, so this is the summary. Does the codec matter for us, for me, as a IP switch provider? Not at all. Because codecs, type of H.264, MGPEG 2000, good SDVOE, doesn't matter. It's multicast at the end of the day for switchers, okay? Is the latency a problem or should be a requirement? Not at all, because I told you now, switches have microseconds between hops. You calculate latency in milliseconds, if not in video frames, so it's irrelevant. So any switch should do. So you don't have a specific requirement for it. Bandwidth is the big requirement, because first of all, you need to know which speed on the TX and RX is. So 10 gig, for instance, I go for a 10 gig switch, that's obvious. But don't forget the interconnect, okay? Because the interconnect will be this blocking thing. And last but not least, multicast IGMP is an absolute requirement for you. So you need to specify, if you are at the planning stage, switches with IGMP snooping and IGMP querier. And there is a third one that I just mentioned now. It's called IGMP fast leave. So IGMP fast leave is just accelerating the whole thing. It's more complex than that, but the direct effect is when Jay will show you how to move one source to the destination, she will do it, and boom, that is happening because the subscription, the queries, all that is super fast, and that's usually what you want. So fast leave should be in the bundle. It should be there. So 3 things. Yes?
So I assume that SDVOE then is specifying break before make in the IGMP joint requests, or can you handle also make before break?
Um, I would like to answer that real quick, make before break. Most likely. You know, I think we are most, no, I think that the correct answer should be the SDVOE technology is sending instructions to receivers only, okay, on the right-hand side, and they force them to emit IGMP joins and IGMP leaves. That's what they do.
Okay, but if you do a make before break, you're joining a second stream before so that you can have a...
Yeah, but this is handled by the technology because don't forget, an hour ago or so you had multi-view on that screen. So the IGMP technology handles multi-view in such a way that you have a main feed, a main multicast stream address on the receiver, and then this receiver is going to subscribe to a bunch of other sources, secondary video sources. So it's going to subscribe as a receiver to plenty of other smaller scale video alternate feeds. So I don't think it's relevant because I think that really, if you do the packet sniffing, it's really a very strict IGMP leave, IGMP join mechanism, and it's really well done.
Okay, but so you're first leaving and then joining the next one?
If
because otherwise you're doubling the bandwidth.
No. If this is the case, the SDVOE technology will never saturate the bandwidth because, let me recap, you have one transmitter emitting 9 gigabit up to 9 gig of main source and a very tiny secondary source for multi-view. So the additional subscriptions on the receivers are made on this tiny secondary downscaled version of the video so that it doesn't saturate at all because you still have 1 gig for all that as an available bandwidth in the worst case. So you do not subscribe to two native videos. You are subscribing to one main and to the smaller ones. And all that is covered because we have 1 gig of available bandwidth, even with 4K 60 444, which is meant to do that. I hope it answers the question. So it can be anything like that, because as soon as you will move a mainstream to a decoder, the decoder will leave first in that case, yes, if this is the main one. I hope it helps. And Mike controls everything I say. Usually he stands up when he says, no, you're wrong, but it's okay. So now we have to wrap up. So the bandwidth, I was explaining it. I'm going to go faster. The transceivers are used, because fiber, you need to know which kind of fiber links you have to use the appropriate transceiver. I hope you're familiar with that. There is a rule. You really must have the same type of transceiver on both sides. Okay, you cannot have a single mode kind of a short range transceiver on the left and a long range other transceiver on the right. Will not work. You are meant to use the same type, maybe not the same vendor, but at least the same type, because there is no auto negotiation, never. So 1 gig, 10 gig, and for your convenience, when you will get those slides, you will see that based on the nature of the fiber, single mode or multi-mode, and then based on the diameter of the heart, the core of the fiber, 50 micrometers, 62.5 micrometers, you will be able to pick the right transceiver for the right distance for your needs. Okay? So I'm sorry, this is nothing I can do to simplify further, right? I mean, this is how Ethernet works, and with such a small table, you should be able to select the right transceivers and ask them to J. One thing is sure, is that if you have a retrofit to do, if you have new wiring to install, go single mode right now, okay? Because multi-mode is dead. Multi-mode will not scale on the road to the terabits mountains, okay? Multi-mode is good for 10 gig, but as soon as you go 40 gig Ethernet, it's already 100 meters limitation, and most likely with 4 links, unless you go bi-directional, becomes a little bit tricky. And for 100 gig, it's done. It's 100 meter, 4 links. So it's much better now to go single mode, especially when you know that the cost of the single mode fiber is down. I mean, big time. It's less expensive than MMF. And second, the termination of these fibers, single mode, used to be complex in the past. You know, big trunk of tools. It's over. I mean, now you can terminate single mode fiber real quick, real easily with a lot of new technologies. And one fiber vendors is in the alliance, by the way. Okay, so single mode, because you can go 100 gig and further with just one link, okay, with single mode. So multicast now, well, we need to configure it, but this is the summary, right? You must have those three things: fast leaf, query v2, snooping v2. If you have v3, good for you, right? v3 is backward compatible with v2, but v2 is what you require. Now, for the sake of today's explanation, you should not configure multicast port by port, because it's fastidious. You can forget some. So either you go port by port, either you actually want to go at the VLAN level. And because any switch out of the box, it's VLAN 1, it's better, more efficient, faster to configure VLAN 1 for multicast. You have the choice, right? So you do it once for one VLAN, you're done. Okay, instead of configuring ports one by one. Now the multi-switch, again, problems. Because in one switch, life is good. Multiple switches, life becomes difficult. Because when you have multiple switches, multicast is not meant to travel, you know? Like, I'm traveling, you know, from one switch to the other. Most switches block it. They block it. So you need to open it up. How do you think you are going to open it up? My answer to that is that right now, with the current state of the technology, you should, when it's possible, always use the stacking feature of those switches. So stacking is obviously an algorithm. It's the way we connect switches together. And when we stack those switches, we are going to allocate certain ports to the stacking mode, stack, and you get a virtual single logical unit. So because you're back to the single switch, life is good again. Okay? Because the algorithm is taking care. All the efforts, hours, months, years of technology enhancements that we've made, us networking vendors, were for that. Giving you a good experience across a virtual network, because you put switches together in stacks. So in stacks, life is good. When you do not stack, because, I don't know, you did not pick the right stackable switches, so you got standalones instead, you need to work with a capability on those switches called the multicast wireless mode. It's not layer 3. Don't be confused. It's not layer 3. It's a layer 2 feature, again invented by Cisco 20 years ago, M-wireless mode. So you will open up that M-wireless mode on both ends of your links, or not, just one end. And depending on how you do it, you will allow for the flooding somehow. Okay? So it's fastidious. There is some progress to be made. Every vendors agree to do that. Cisco always will want to go layer 3, OSPF, PIM, very complex things. Instead, I'm telling you, trust me, okay? If there is one thing you need to trust from me, is that if you go with a good stackable platform, you put together your switches in a stack, you stack them, and we are going to do it as a conclusion, you will get rid of any of these horrible complexities, because you're back to the good IGMP single switch situation. Everything will work flawlessly. Okay? So, this is how we do it. If you log onto a switch, so of course this is a Netgear GUI. I'm not going to take a Cisco GUI to put it there, right? I mean, so, and I would actually be at fault doing it, right? They don't want me to do it. So if you go to a Netgear GUI, you have the system layer 1, switching layer 2, routing layer 3, QoS security, they're all the same. And if you go to the switching multicast submenu configuration on the left, you will then enable IGMP, because now you know that it got to be enabled, IGMP globally mode. And if you have some options down there, header, querier, just say yes to everything, okay? Because it's meant to do that. Now you see that you could configure interfaces just under. Don't go there. I don't want you to configure 48 times each port. So instead, you click on VLANs, and I'm going to do that once for all for VLANs. Let's see. Now, querier is also something you want to enable, because you know it's crucial to have an IGMP querier on your network. So I go to the querier configuration, just under it. I'm going to enable it globally. If you know that there is another switch right there that you want to point at, enter the IP address. The 000 means it's a dummy. It's going to divert. It's going to be revert back default to the switch IP address. And then you obviously want to do that for the VLAN 1, enable it once for all. So you have IGMP snooping, IGMP querier set up for the VLAN 1 with just 1 or 2 clicks. In the VLAN configuration for the snooping, you also have to enable the fast leave, the last thing, and you're done. Okay? Those 3 things, it's an absolute requirement. So some other vendors will make it a little bit more difficult. Obviously, the switches should, by default, kind of restrict any unregistered traffic, so that, if you have some pollution coming from somewhere else on the network that you hooked up, you should get no pollution, no flooding, so that's a default as well. Now, if you have a problem, where should you look at? If you have your IP-NINJARs, despite the fact that you move one source to a destination, if it doesn't work, but from a IP-NINJAR controller situation, everything looks okay because the controller got you, now I hope you know that it should come from the network, right? It should come from the IGMP management. Something got wrong. So the place where you should go on Netgears, but on any other switch, should be the multicast forwarding table, not the MAC address table, the multicast forwarding database, where you should see one way or the other which ports have which multicast addresses. Which groups. Because if you ask the port number 1, which is a transmitter, to be in contact and send videos to the port number 10, which is a receiver, you should see an IGMP group with the port 1 and the port 10. If you don't, you know it's IGMP that is not working. Maybe you did not configure it. Okay? Okay? This is essential, very important. Now, well, good news. Oh, go ahead. Yeah, no, that's a good point. So what is the syntax of the forwarding port interface? So you have a little tiny, adorable Netgear switch in the middle of the rack over there, and it's a half width, and you see the port numbers on there. So port number 1, 2, 3, 4. This is the last digit. The switch got a number because when the switch is standalone, it's still a stackable switch. So it's the switch number 1. In its own stack. So this is the unit 1. And the 0 in the middle means the physical layer. So the 0 means the physical interface. When you are going to create LAGs, link aggregation groups, it's going to be 1. And plenty of other numbers when you create virtual interfaces for routing interfaces and all that. Okay, so the Netgear syntax is the unit, the physical layer, so 0 is physical port, and the port number. That's pretty standard. I mean, I'm pretty sure half of the manufacturers in the world do the same. Cisco does the same. So I was saying that you're lucky, I hope, because we have worked out all this for long. And we have a line of switches called the 43s that ship out of the box with everything I've just said, pre-configured. So we really wanted to accelerate, facilitate, the user experience. So if you have a venue for an event, and if you take out the switch out of the box, plug all the IP-NINJARs and all that, the controllers, everything you want, the controller will discover everything, you will move the videos, and everything is going to work. Because we pre-configured on the default VLAN, IGMP Snoop, Querier, and Fastleave. Okay? So this is essential, and at this stage, and to the best of my knowledge, believe me, I'm paid to control. Nobody else did it, because when you do it on a switch platform, let's say a Catalyst at Cisco 2960X or 3850, you are going to break a whole lot of other functions, because IGMP is kind of competing against MDNS Bonjour packets, or Bye Bye Dante, and a few others. And we figured out. So we spent a lot of time working closely with SDVE and all IDK and all vendors to facilitate their life. But we did not, I mean, we fixed all the associated issues that are on most other switch platforms when you enable those things. Okay, so those switches are still capable of doing everything else, but allowing good user experience. So VLAN 1, and of course now if you have another VLAN, you need to redo those three things that we've done together for another VLAN.
Are there any changes to make on the spanning tree when
No.
using multiple switches?
No, because when you stack the switches, then it's a single switch, so by definition spanning tree is gone. And the Netgears ship with rapid spanning tree enabled by default, so that you have the spanning tree negotiation all good when you do links between switches. And if you do a loop, that loop will be shut down by admin mode down in that case. Okay? So we pre-configured spanning tree as well. It's kind of Chinese for a few others here. So spanning tree is a redundancy protocol that is used to give some backup routes. Okay? So this is pre-configured, and I do not have time, but these are the 43s, 1 gig for Dante audio and all that, and 10 gig. The good news is that they all stack together. So this is a good platform that can scale up to 8 switches. The last guy down there has 96 ports of 10 gigs, so 8 times 96, that's a whole lot of ports. So you can scale quite good. 1 gig, 10 gig, or vice versa. PoE on most models, including the 10 gig. And the 96X is that switch that we love. Many of our customers now like this one, because this switch is empty. Remember the obsession, you want to grow. So I believe this is the switch that the Opera House of Zurich selected. I'm pretty sure I met them at ISC in February. They loaded half of the switch, not even, right, with those 8-port modules, so that they are small now, but they know that in the future, should they need more TX, RX, they will just plug additional module cards. So this is a modular switch, not a chassis, just a single dump, but good modular switch. Okay? The Netgears are €100 per port, all models pretty much, so it's really cost effective anyway. The configuration is over there. And if Jay wants to give me the 5 final minutes, okay. The market share, it will be for another day. Are you ready? Because we have 5 minutes, so let's go to the point. The conclusion of today's session was, well, you guys are going to tell me how you want to deploy now a 144-port SDVoE system, 72 transmitters, 72 receivers. 72 10-gig transmitters and 72 10-gig receivers, all line rate together. Well, so let me first give you one hint. Any port can have bidirectional communication, remember? Bidirectional. So that is going to help tremendously, because you are going to be able to do some savings on the interconnect because of that. So 72 inputs and 72 outputs, this is the solution that you are going to configure now. Okay? You are going to take 3 switches, preferably a 96X model, because it gives you some flexibility on the ports. You can select 10 gig copper power, 10 gig fiber, whatever, for your 24 transmitters, 24 receivers on any switch. And we don't want to do standalones kind of IGMP multicast routing mode. It's really cumbersome, believe me. Instead, you are going to stack those switches by assigning a mission to those 40 gig Ethernet ports on those models. We are going to tell them, you guys are stacking ports now. And by doing that, you virtually assemble those switches in a big chassis, kind of, and you get rid of any IGMP complexity. So are you all in agreement there? Are we totally sure that if I have 6 ports of 40 gig, upper left, going down, so 6 times 4, 24 times 10, 240 gig of bandwidth, going up and down. If I go down to the second switch, if the switch in the middle at the bottom got 6 times 40 gig going left, 6 times 40 gig going right, same symmetrical architecture up there, can any transmitter send a 10 gig stream to any receiver in that topology? I heard one yes. Oh, I have one no. 2 no's. 3 no's. How many? I don't know. A whole bunch. Okay. So nobody agrees with me, and the other majority actually barely believes I'm capable of doing that. So that's great. We are in a good shape. So I'm telling you, this is how it must be done. I mean, you can do more than that, but this is the minimum you need to do. Why? Because I guess that why some of you, the most experienced guys in the room, believed that it was not working was because what if the 24 receivers down there on the switch at the bottom are sending 24 streams up left? What if the other 24 guys up there are doing the same, using the same way? You are going to have oversubscription on the left. But you forgot something. How many receivers I have up there? So what can they take? At the very best, they can take 24 10 gig streams, not more. So you are covered because you are dividing by 2 the interconnect requirements. Okay? Of course, if you want to add some level of redundancy, because if the switch down there is dying because somebody pulled the plug, you have 2 power supplies, right, on those one full width. If you have 2 PSUs, please do not connect both to the same UPS system, because, well, if the UPS fails, you're down there back to the point of failure. So two PSUs mean 2 power sources. But if that guy dies, well, your switches up there are not connecting each other, right? So you could, because you have some ports left, add redundancy by, adding stacking ports. That is just because you want to add redundancy, not because you want to provide more bandwidth in that case. Okay? So this is the scheme, 1, 2, 3. I'm going to create the stack by going stacking on the first switch. This time it's another piece in the menu. Going to the first switch, I'm going to give him a big priority so that because I want it to be the manager, the master. Second step, I'm going to click. Yes, sorry. I wanted to tell you that before doing the 3, we just do the 2s. So that it's 2 and 2, very simple to understand. I'm going to select 2 ports, going to stack mode, configure it, save it. But the running mode will still be Ethernet. It requires a reboot, you'll see, in order to get that mode running. Then we do that on the second switch, lower priority in the stacking menu, 2 ports, stacking mode. I am going to save the config and reboot each of these 2 switches. And you have 90 seconds to put your cabling together. And when it has booted 90 seconds later, connecting to the first switch, you see 2 layers, 2 levels. You have 2 switches, you have formed your first stack in your life. Okay? Very easy. And now it's very solid. If you pull the plug, reboot, whatever, that will always come back to a stack. It's redundant. It's very well designed. That's the goal, right? The design is for it. So, of course, lazy guys like me click, 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 click in the GUI. That's really, after a while, you kind of prefer the command line because it's a syntax that you can copy and paste. You can actually get a small cheat sheet, and then you can log to the first switch, priority 15, stack port, unit 1, 0, 14, 16, save, exit, done. Logging to the second switch, you're done. You show the switch in the first switch again after the reboot. You have your stack that is comprised of 2 individual switches. So back to this example with those IP-NINJARs, 24 and 48, and yes, I know I'm not an artist. I'm going to log to the first switch. I have more ports to configure for the 40 gig, the switch down there, all the 10 gig ports. And this time for the syntax, the middle number are the slot numbers, slot 1, 2, 3, 4, up to 12. So you have the slot number in the middle. We are configuring the stack mode. We exit, and save. We do the same on half the port switch number 2. We did the other half of the port switch number 3. You have to reboot each of these switches, reload or reset, both works. And then when the switch are booting, you can physically connect them, and 90 seconds later, you have a working stack. And your IGMP is going to be good, robust, rock solid for 72 by 72 for approximately 100 euros per port. Sorry, I extended a little bit my time, but I promised I'm done. That's it. Any question? No? Thank you. Yes.
I saw on the beginning of the presentation a Netgear card with HDMI input.
That's right. So I will not talk about it now because Jay and Mike must absolutely do their tour. So let me just tell you that these cards are not Netgears. Charles said quickly that they were designed collectively by the Alliance. We, Netgear, opened up the switch as a platform, that's all. And we allowed them to do this, okay? And some SDVW vendors started, and I'm pretty sure that plenty other vendors will come down the road, do it as well, because the value is not there. The value is in the controller, the software, the management. But you have a card that is built with 4 encoders directly on the card. So as Charles said, instead of having transmitters attached, you can directly attach HDMI local sources on those ports in these switches, which is a great idea because it will further simplify the design by removing the T-axis from the rack on the video room. So that's pretty cool. And I'm very proud and excited, but it's not today's topic because, well, first, it's not ready. Second, IDK has a better to tell you about right now. But it's coming. I expected to see the first units hitting the streets by October timeframe. So it's not Netgear, okay? It's my switch, but it's not my cards. Netgear will never do AV. Netgear will never want to compete with any of you.
Wouldn't it be a very expensive solution to get an HDMI in there?
Well, so
Because
I am
as the 100 euros per port, you're sacrificing quite a lot of ports.
yeah,
I
you
think.
sacrifice 4 ports, but in exchange, you have a whole lot of savings on the T-axis. And I believe that if you go to Google and Google it, some vendors already communicated their expected street price. It's going to be much, much, much more lower per transmitters this way because you get rid of PSUs and components, So no, it should actually lower the cost of the installation all in all. But yes, you cannot scale to 96 devices anymore. You divide by 2 in that case. But it's not meant to, right? The receivers are still meant to be elsewhere. The sources, local sources should be using it. And even if it's not a device that is IDK, for instance, IDK controller will manage them, greatly anyway. Thank you very much for your attention. Thank you.